All right, hello everybody. Welcome back to my channel. Welcome back to the stream. Welcome back. I hope you're having a wonderful day so far. We are taking a jump back into computer science, learning Python today, just like normal. Sorry about the late start today. I had a late day at work, and I was really busy today. Um, yeah, I appreciate you guys coming in. Today is January 28th, 2025, a Tuesday, and we're feeling real good. Um, we so I actually at work I was late today because I was doing a large scale filtration of my product, and it started at 1 o'clock and didn't finish until 6 p.m. So or like and then I had to clean up and then drive home. So it took me about an hour to clean up because I was solo. My partners bailed out. They had to leave. But anyways, I appreciate you guys joining me tonight. Hey Mahan, welcome in. How's it going? Magnet, welcome. Awesome to hear from you guys. Quick into the stream, you guys must have been waiting on deck for it. Appreciate you guys jumping in here and saying hello. How you guys doing today? All right. How are we doing out tonight? Okay. So I took your guys' advice or whatever, and or not advice, but your guys' suggestions, and I watched those videos on insertion sort, and I did a lot of research on my lunch break and stuff regarding it, and I was able to kind of implement the insertion sort in Python, just in my own Python file, and so we're gonna have to try to convert that into the specific problem now. Um, Now, I want to walk through it with you guys when we get there, just so we are all on the same page. But we're only 4 pages or so away from completing this chapter, so I kind of wanted to just bang it out today and finish it up, and then be done with trees, chapter 8. We've got to get some practice problems on these guys. So let's just jump right in here, you guys, to chapter 8 here. All right. On 346, the Euler-Tuor traversal of a binary tree. Sorry, pardon me. In section 8.46, we introduced the concept of an Euler-Tuor traversal. So if you guys remember from yesterday, an Euler-Tuor traversal is where we are starting down depth, starting from the left when facing the tree, right? When facing the tree, we start with its left side, but when we're actually traversing down, we kind of flip our view vision the other way and start walking down the depths of the tree. So the nodes in the left branch are on our left side as well. We kind of hover around these nodes, having a pre-order visit at each position, and then back up, kind of tracing the outline of the tree itself, having a pre-order visit on our left, on the node's left, and then having a post-order visit on our left as well, but the node's right this second time around. So we learned about that yesterday. We introduced the concept in Euler-Tuor traversal of general graph. Using the template method pattern in designing the Euler-Tuor class, that class provided methods underscore hook underscore pre-visit and underscore hook underscore post-visit that could be overridden to customize a tour. In code fragment 8.33, we provide a binary Euler-Tuor specialization that includes an additional underscore hook underscore in visit that is called once for each position after its left subtree is traversed, but before its right subtree is traversed. Our implementation, so if it was a binary, I know this example isn't a binary tree in person. Well, to technically, actually, it is, right? Each node has no more than two children, or none, or one, right? So I think it might actually be. It just doesn't have this leaning even portion over here. But so what this call is doing, the in visit hook is called once for each position after its left subtree is traversed, but before its right subtree is traversed. Our implementation replaces the original tour utility with a specialized in the case in which the node has at most two children. If a node has only one child, a tour differentiates between whether it has a left child or a right child. with the in-visit taking place after the visit of a sole left child, but before the visit of a sole right child. In the case of a leaf, the three hooks are called in succession. Okay. So we have binary Euler, which inherits from the Euler tour. So our tour function in this case takes in a position, a depth, and a path. Results will update with results of recursions. Okay. Underscore hook pre-visit, position, depth, path, pre-visit for P. So before you get there, you call the pre-visit action. Then you do the traversal on the tree if it has a left child. You do a tour on the left position at a depth +1 given the path, and you append that to results. And then you pop the path at each stage. Okay. Then you call the in-visit, and then you do the right. Okay. Hey Tim, how's it going? Welcome back in. How you doing? Okay. To demonstrate use of the binary Euler tour framework, we develop a subclass that computes a graphical layout of a binary tree. As shown in figure 8.22, the geometry is determined by an algorithm that assigns x and y coordinates to each position p of a binary tree T using the following two rules. X of p is the number of positions visited before p in an in-order traversal of T. Y of p is the depth of p in the tree. In this application, we take the convention common in computer graphics that x coordinates increase left to right and y coordinates increase top to bottom. So the origin is in the upper left of the computer screen. So origin is in the upper left here. 0, 0. Code fragment 834 provides an implementation and in-order drawing of a binary tree. So what does x mean? X of p is the number of positions visited before p, and y of p is the depth. So depth, okay, increases at each place. And then you go all the way out here because you have filled in positions here. Oh, so this is like the positions in our array almost. So you'd have these are the values associated in the array. Okay. Code fragment 834 provides an implementation of the binary layout subclass that implements the above algorithm for assigning x and y coordinates to the elements stored at each position of a binary tree. We adapt the binary Euler tour framework by introducing additional state in the form of a underscore count instance variable that represents the number of in-visits that have performed. The x coordinate for each position is set according to that counter. So we have a count instance that represents the number of in-visits. Okay. So binary class, initialized with tree, count equals 0, hook in-visit on the path, depth, and on the position, depth, and path. You access the element at the position, you set x to the count currently, which is 0. Okay. And then you set y to the depth given. Okay. And then you increase the count by 1. So the root then in this case, oh, you call count each time you said the number of in-visits that have been performed. So 0 in-visits is here. Why is it not at the root? All right. A binary layout class that computes. Okay, gotcha. In example 8.7, we introduced the use of a binary tree to represent the structure of an arithmetic expression. In this section, we define a new expression tree class that provides support for constructing such trees, and for displaying and evaluating the arithmetic expressions that such a tree represents. What you doing, kitty? Kitty's creaking the door. Let me go ahead and copy over the header here, so we're on to 8.5. Case study and expression tree. What are you guys working on this evening? Let me know what you guys are working on or studying. In example 8.7, we introduce the use of a binary tree to represent the structure of an arithmetic expression. in, this in this section, we define a new expression tree class that provides support for constructing such trees and for displaying the and evaluating the arithmetic expression that such a tree represents. Our expression tree class is defined as a subclass of a linked binary tree, and we rely on the non-public mutators to construct such trees. Each internal node must store a string that defines a binary operator, and each leaf must store a numeric value or a string representing a numeric value. Our eventual goal is to build an arbitrarily complex expression tree for compounding arithmetic expressions such as, these ones. However, it suffices for the expression tree class to support two basic forms of initialization. Expression tree value creates a tree storing the given value at the root. Expression tree, given 3 parameters here, create a tree storing string OP at the root. Okay, create a string storing the operator at the root, and with structures of existing expression tree instances E1 and E2 as the left and right subtrees of the root respectively. Okay. So you can that's how you create that node operator and then have the E1 and E2 be its children. Such a constructor for the expression tree class is given in code fragment 835. The class formally inherits from linked binary trees, so it has access to all non-public update methods that were defined in section 831. We use addRoot to create an initial root of the tree, storing the token provided as the first parameter. Then we perform runtime checking of the parameters to define whether the caller invoked the 1 parameter version of the constructor, in which case we are done, or the 3 parameter form. In that case, we use the inherited _attach method to incorporate the structure of the existing trees as a subtree of the root. Composing a parenthesized string representation. A string representation of an existing expression tree instance, for example, as this expression, can be produced by displaying tree elements using an in-order traversal, but with opening and closing parentheses inserted with a pre-order and post-order step, respectively. In the context of an expression tree class, we support a special stir method that returns the appropriate string. Because it is more efficient to build a sequence of individual strings to be joined together, the implementation of the _stir relies on a non-public recursive method named _recur that appends a series of strings to a list. These methods are included in code 835. Okay, so we have our expression tree, which takes in a linked binary tree. When we initialize it, we have some token and a left and right assigned to none. In a single parameter form, token should be a leaf value, 42, and the expression tree will have that value at an isolated node. In the 3 parameter version, token should be an operator, left and right should be an existing expression tree instances that become the operands of the binary operator. So we super the initialization from the parent. If the is instance of token is not a string, we raise this type error, so token has to be a string. We addRoot the token. If left is none, meaning that there's no left child, and if token if left is none, and if token not in this string, it's not one of the operators, we raise a value saying that the token has to be a valid operator. Else we attach to the instance the root provided to the left and right. Gotcha. So in our under stir method, we have a pieces list. We call the parenthesized recur method on the root first and then the pieces, and return, and we join pieces. Okay. Parenthesize recur, this is that recursion. If the instance itself is a leaf at that position, we append the string version of the element. So if the element is 42, we append the string. Else results.append the left-hand parenthesis. We call it parenthesis recur on left p results.append, and you do the same thing for the right. Interesting. Opening parentheses, left subtree operator, right subtree, closing parentheses. All right, expression tree evaluation. The numeric evaluation of an expression tree can be accomplished with a simple application of a post-order traversal. If we know the values represented by the two subtrees of an internal position, we can calculate the results of the computation that positions designates. Pseudocode for the recursive evaluation of the value represented by a subtree rooted at position P is given in code fragment 836. So evaluate recur at position P. If P is a leaf, then return the value stored at P. Else, let this be the operator stored at P. X equals to evaluate recur on the left position of P. Y equals evaluate recur on the right position of P. Almost done here. To implement this algorithm in the context of a Python expression tree class, we provide a public evaluate method that is invoked on instance T as tree.evaluate. Code fragment 837 provides such an implementation relying on a non-public evaluate recur method that computes the value of the designated subtree. So in our evaluate, we return evaluate recur of the root. Here's the evaluate recur of the position. If it's a leaf, you return a float of the element. Else, operator is the element, right? Because only leaves have the actual number. Other things have operators. Left val, reoccur on the left position. Right val, reoccur on the right position. If the operator is plus, return val plus, right? Else is minus, right? Or else return that. Okay, cool. Hey, Sujan, how you doing? Appreciate you stopping in and saying hello. What you working on this evening? What you studying? Okay, we got. All right, this is the last page of the chapter. Whew, almost there, guys. Building an expression tree. The constructor for the expression tree class from code fragment 8.35 provides basic functionality for combining existing trees to build larger expression trees. However, the question still remains for how to construct a tree that represents an expression for a given string, such as parentheses 3 plus 1 times 4, whatever, yada yada. To automate this process, we rely on a bottom-up construction algorithm, assuming that a string can first be tokenized so that multi-digit numbers are treated automatically, and that the expression is fully parenthesized. The algorithm uses a stack S while scanning tokens of the input expression E to find values, operators, and right parentheses. Left parentheses are ignored. When we see an operator, we push that string onto the stack. When we see a literal value, V, we create a single node expression T tree storing value and push T onto the stack. When we see a right parentheses, we pop the 3 items from the stack. which represent the sub-expression, right? The current, you pop the first one, which is E2, you pop the operator off, then you pop E1. We then construct a tree T using trees for E1 and E2 as subtrees of the rooted storing operator, and push the resulting trees back on the stack. We repeat this until the expression E has been processed, at which the time the top element on the stack, at which time the top element on the stack is the expression T for E. The total runtime is O of n. An implementation of this algorithm is given in code fragment 838 in the form of a standalone function named build expression tree, which produces and returns an appropriate expression tree instance, assuming the input has been tokenized. Right, so build expression tree of it given some tokens. So we have a stack here for T in tokens. If the token is one of these, right, we're going to append it to the stack. If T is not one of these, a parenthesis, we append the literal value. If it's the right parentheses, we pop all three off, right, append those onto an expression tree, and return s.pop that value. Awesome. Woo! All right, let's get them thumbs ups in chat. Let's get some emojis in chat here. We are done with chapter 8 on trees, at least for the reading. Nice. It's been a long one. Let's get a nerd cluster here for reward. Hey, welcome in, Ryan. How you doing? Welcome back. These nerd clusters, they really make me I have to rinse off my mouth. Okay. All right, let's go ahead and maybe take a stab at one or two of these real quick and give them a try. And then we can go back and move on to the leak code problem from yesterday. Chapter 1. No, what happened here? What happened here? Yeah, what happened? Okay, we need to go chapter 8. Chapter 8 notes. How did I write that in? Oh, whatever. No, delete. Okay, let's go. Here we go. Chapter 8. I'm gonna make sure I got my formatting right. R 8.1 underscore key.py. All right. Sujan says, I was organizing sorting notes. I got to organize recursion and hash map notes too. I'm definitely going to start quick and heap sort today. What about you? Yeah, just finishing up some DSA chapter 8 on trees here. Going to try a practice problem, and then we're going to jump back into the leak code problem from yesterday that we got stuck on and couldn't solve. I did some studying on insertion sort today on my lunch break, and while I had some time while my stuff was filtering, and I was just sitting around waiting for it to filter. I did some research on insertion sort here, and I was able to work alongside with Jippity, the almighty orb, and have it kind of coach me through actually building one of these in Python. And so I was able to do it for just a basic array. So we're going to try to actually implement this now into this array. So we're going to really go through it and make comments and stuff throughout it. So we'll get to that right after this problem here. Okay, so we're on 8.1 here. Which of the following questions refer to the tree in figure? The following questions refer to the tree figure 8.3. Okay. How did I do these last time? I just did. Okay, I copied the question in a what are these called? Can't remember. Hey, Wing Hong, welcome back. How you doing? Awesome to hear from you. The following questions refer to the tree of figure 8.3. Okay, let's go like this. A. Which node is the root? What are all the internal nodes? Okay, hold on. Let's go to the figure 8.3. Is that 8.3? No, 8.21. Way back here. This is figure 8.15. Um, 8.6. 8.3. Here we go. All right. Which node is the root? Obviously, the user RT courses is the root node, right? This guy here is our root. Okay. B. Not too hard so far. What are the internal nodes? What are the internal nodes? So are internal nodes just every other node that isn't a root? Do we have it in our definition? Internal, a node that has one or more children. Okay, a node that has one or more children. So this node has one or more children. Right? So does this guy, CS016 slash. So does the CS252 slash. Grades does not. Homeworks does. Right? And so does programs. Those children are, was it one or more or two or more? One or more. Okay, so those are good. That one we got already. So projects slash. Grades is not. Papers is. And so is demos. And that'll be it. So I'll say here, internal node are nodes with one or more children. Like so. Hey, Leon, what's going on? How you doing? Welcome back in. What you working on this evening? All right, let's do C here. How many descendants does node S or CS016 have? So descendants. So are descendants direct, or can they be, multiple? They can be skip depths, right? So let's go to our notes here. Do we have ancestor? Node U is an ancestor of V if U equals V, or U is an ancestor of the parent of V. Conversely, we say that a node V is a descendant of node U if U is an ancestor of V, right? Node U is an ancestor of node V if U is equal to V, or U is an ancestor node U is an ancestor of V. So okay, if U is an ancestor of the parent of V. Huh. A node can be an ancestor of itself given this definition. Um Hey, Kushiger, appreciate you coming in. Thanks for joining me. This is Data Structures and Algorithms in Python. For those that are new here, I'll just quickly introduce myself. My name is Michael. Thank you so much for joining me here. I've been teaching myself Python for about half a year. More specifically, we're starting to dive into some more deeper computer science topics. But I have been teaching myself, like I said, for about half a year after my 9 to 5 job as a chemist. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company. Uh, and so, yeah, I just really enjoy computer science, learning more about um, math and everything. And it's really interesting. And so we've been teaching ourselves this and making projects. And so the data structures and algorithms book you see on the right can be found online or in my Discord as well, linked below in the description. Completely free. It's just like a roadmap. Also, a lot of other people resources, a hangout, an offline hangout, Discord. For the channel members to get access to all of my personal study resources, like you see my notes here and the books, as well as the Python crash course that we read on the stream already. So if you guys have any questions regarding the content, feel free to let me know. Thank you so much, Kushigar. Hey, David, how's it going? Yeah, been a while. Just had a chem midterm, Leon said, which I was pretty confident in coming in. But going out, I was so frustrated. For one problem, I had gotten a completely different answer from the choices, but I forgot to convert back to Celsius. Ah. Do you remember any of the problems? I'd be curious to see if I knew them. Some dumb mistakes, but school is kicking me right now, and nothing we can do but move forward. Yeah, just roll with those punches, man. It's only gonna just make you better, right? You only be able to accomplish, more coming out of that on the other side. Okay. So, how many descendants does node CS016 slash have? So, has descendants. So, one, two, three, four, five, six, seven, eight, nine descendants. So let me go ahead. I'm going to go screen shot. I'm going to take this guy. Capture. You can copy this guy. I'll go here. How many... Uh-oh. Descend... Ugh. I'm not going to be able to spell this word. Descendants does CS016 have? I say 9. Dun dun dun. Let's count the descendants. Grades, homeworks 1, homeworks 2, homeworks 3. Programs 1. Total equals 9. You're correct. Okay, cool. Nice. Keep on moving here. I like this. Not too hard yet. How many ancestors does node CS016 have? So remember from our definition though, a node can be an ancestor of itself. So would it be 2 or 1? What do you guys think? Does CS016 have 2, including itself for ancestry, the node itself and its parent, or just 1, its parent? There's a part in this book that mentions that node U is an ancestor of node V if U is equal to V. So maybe like they're twins almost in parent sibling relationship, but twins? I'm not sure. What do you guys think for option number D here? Hey Ryan, welcome back. I know this is not CS50X. Currently, I started off late today. I got off work really late, later than normal. I was caught up doing a big bulk filtration. So it took me like 5 hours to complete just alone, and I had some other stuff I had to do before that. So it was just a really long day, and I got off work late. So I'm going to push the CS50X Week 4 live lecture watch to tomorrow. So I apologize. Please bear with me. We are actually ahead of schedule though. We are currently 4 weeks down, starting from 0, 0, 1, 2, 3. We're 4, 0, 1, 2, 3, 4 weeks down with the course already. So we technically are done with January already. Like we already done with the 4 weeks of January because we started January 1st. So we are a little bit ahead of schedule. So we do have a couple of days of leeway. So I decided to push it today. So we'll just do a short hangout here, before it gets too late. And I just did have a long day at work. Just sent it off in topic. Feel free to check out Evernote to feel like the answer is K. All right, let me see. I haven't done chemistry problem homework in a long time. Let me see here. I also trolled 19. I said, okay. Let me see here. An endothermic reaction. So you remember an endothermic reaction consumes heat, consumes energy. Um, it doesn't expel heat. So a negative delta H absorbs heat from the surroundings and feels cold to the touch. A negative delta H gives off heat to the surroundings and feels cold to the touch. A negative, so this is, I hate these kind of problems because they just invert what they all say and you have to just get the right combination. So a positive delta H, a change in heat. What does big H stand for again? I haven't used big. I'm gonna be honest with you guys. If you go on outside of chemistry, you don't really use a lot of these things you learn in these classes. I mean, they stick with you with just basic understanding of lab techniques, but you start building like people's products and medicine, and you get into what people actually care about, like selling their products and hiring chemists for that. But if you do like R&D, maybe I bet you get into this kind of stuff. Um, so it definitely absorbs heat, right? So it's definitely not going to be C or D. Absorbs heat and feels, you say feels warm to the touch. Well, if it's absorbing heat, it probably will feel warm-ish, right? That you would think because heat is currently coming in. So unless it is like seriously freezing cold, which is probably not. I just can't remember what the positive delta H is at the moment. I have to look up what delta H is in my old chem notes. Nice. Um, you said number 22. Let me look at that one. This is fun. The root mean squared speed. Oh, geez, come on. The root mean squared speed for a sample of ammonia gas, which has a molar weight of 1704 grams per mole, was determined to be accelerate or that speed meters per second. What is the temperature of the sample? Oh boy. Do you have your equation sheet? Yeah, you have some equations here. So you have uh, mu is equal to 3 RT over M. Then you square over, that looks good. You divide by 3. You have RT isolated. And you solve for temperature. Yeah, did you convert back from, what is the what is the given temperature? You're in joule for R, so your temperature would probably be in Kelvin. So did you convert back to C from your answer given in Kelvin initially? Yeah, I'd have to look back on those little properties on exothermic, endothermic. I think it kind of depends on the actual medium, right? In some circumstances, because if you're absorbing heat, you might be warm to the touch because you're taking in heat. Um, in terms of reaction, no, but exothermic would be hot, so it'd be cool to the touch. Because the exothermic one, I mean, or would they both be warm to the touch? but exothermic would just be a lot hotter. I had to think about remember those principles. I deal with a lot of like individual circumstances at my work now, so it's no longer like textbook. It's like, what do you do when we have a crisis right now? This won't work. Well, what do we do now? How do we solve it? And we fix that. So it's no longer just like right or wrong answers in a textbook. Um, yeah, my prof also personally puts wrong answers in there you could have gotten with calculations and choices, so he messes with you. Ah, yeah, those professors are kind of brutal. I honestly don't. It's not very like I don't know. Yeah, and that's what I'm saying is I honestly looking like on my chemistry notes and my like if I were to have to take like a general organic chemistry exam right now, I don't think could be able to do like that well. Like I probably could do decent like in terms of inferring stuff, but I've just been so accustomed to like being in the field now and just building products that like my way of thinking is all like to actual application and process now and no longer like taking in chemistry uh, factoids or whatever from textbooks and stuff, like we're doing with CS right now, right? I bet you people that are computer scientists, right? They like a lot of people say that DSA is only just used in their that screening to get in. Some people say that once they become computer scientists, they never even really mention this stuff ever again, or a lot of it's kind of already implemented for them. At least from like some of the videos I've watched and people that have talked to me about it, but I wonder what if it's similar to like computer scientists. Once you get out of college and into the field, your problems and you get directly related to the problems the products you're making because you're into the economy now. You're a part of the wheel. You're part of the wheel of the economy. So it's no longer about like education anymore, unfortunately. Okay, so let's ask here how many ancestors would it have? Can it include itself in ancestry? How do you spell that? Oh, I said ancestry. Uh, Ancestry. The ancestors that are directly in the case are the parent and itself if included. By definition, ancestry usually does not include the node itself, only if it's parents, grandparents, etc. So normally has one ancestor. If we allow a node to count itself in ancestry, then it would have two. One not including itself. Because node U and V are not equal. So I think it meant like parent-child relationship where the nodes are actually twins or like the same element, just at different depths. Might have been that one catch. Okay. So then what about this guy here? E. What are the siblings of node homeworks? Siblings. So this would be just grades and programs. Leanne, do you like your chemistry class? Do you enjoy it? What makes you? What are you taking chemistry for? Are you are you wanting to be a chemist or biology or and then you're also into watching me do computer science. So I'm curious to what like your path is. If you want to make project for yourself, you need them. The project I need to use the linked list so I can easily reorder tasks, But if I finished it and expand, I just give it. Oh, you're talking about the DSA. Yeah, if you're starting from scratch, probably definitely need this kind of stuff. I mean, well, even we've kind of implemented some, data structures and proper ways of, uh, you know, fast algorithms within our simple program of the small business manager. So F, what nodes are in the subtree rooted at what nodes are in the subtree rooted at nodes projects? You have papers, demos, You have buy low, sell high, and market. G. What is the depth of node papers? So you have 0, 1, 2, 3. And then E.G. H. What is the height of the tree? So the height of the tree is the longest path or longest, deepest depth. So 0, 1, 2, 3, 4 would be the height. So let's go. What is the height of the tree? Four. Perfect. Nice. All right, that's this problem. That wasn't too bad. That was a good warm up with trees. Now watch it just get crazy on the next one. But I think it's probably time for us to move on to lead code here. Show a tree achieving the worst case running time for an algorithm depth. Show a tree achieving the worst case running time for algorithm depth. Show a tree achieving the worst case running time for algorithm depth. What does this mean? Oh, here we go. Hey, Leon says CS major requirements is a science class and physics, geo, bio schedule was not. Uh, was not. It was a commuter. Oh, CS major requirements is a science class, and physics, geo, bio schedule was not as a commuter. Took Chem 1, did really well for some reason, so taking Chem 2. Oh, gotcha. Might take something else next term, as that will be my last science class. I just did add a math minor, so that's something I'm pretty excited for because I personally hate looking for general electives that have no relation. Yeah, I would. Yeah, that's a good idea. Stick with math. I really want to focus on CS because it's genuinely a passion. Yeah, that's really awesome. Oh, Ryan, you starting a Python crash course? Are you starting this guy right now? Getting started, page one. Just flip to that bad boy. Ryan, I honestly think that, or Trash Ketchum, sorry, I honestly think that, no, with your experience in CS50X so far, you'll fly through Python Crash Course. You'll find that the syntax for Python is extremely vague compared to C, and you'll be like, oh, I'm feel like I'm forgetting things, but then it just it works that way. Yeah, I think you'll be all right. This book is pretty easy. All right. Okay, cool. Let's go ahead and move back on to our leak code problem. So with trees, it's really good for its algorithm wise since it can have multiple children, reaching average O log n for search. But a tree with worst case running time would mean that x nodes, it would have to be O of x to find something. O of n to find something. So why is the tree is log n because you can a binary tree at least because you can divide its children or its subtrees in half, right? And recursively, is that why? It's cold in here. Let's get the blanket up. Okay. Okay, let's move on here to the leak code problem. Oh boy. Here we are. Okay. So let's talk about insertion sort for a second. I want to talk about it with you guys here. So in my research yesterday, Lena, hold on. Lena says, right. So imagine you have an ideal tree with n elements. Each node has 2 children, at most, right? So with insertion sort, actually, I have a fun little idea that I want to try out here. So give me 1 second. 1 second. Okay. Let's try something out here. Let's try a visual approach. Okay. Hold on 1 second. Let me grab my phone. Let's see if we can do something cool here. Okay, let me see if I can broadcast my my phone as my camera. Okay, sweet. We are good. Okay, so this is my setup here. If you guys can't see, behind the scenes, what's going on here. But this, okay, I wanted to try. Oh, I don't think you guys can actually see. Can you guys actually see this? Okay, you guys can't see. Okay, so we are doing insertion sort. Okay, so I have some elements here. Now, these two elements represent the same, like they're the same thing, right? They just have a different attribute. Similar to our problem here, where, similar elements would have, like in the case of 3, they're the same, whatever size, but they have just a different attribute associated with them. So, let's go back here. It's just like this, so, okay. Let's leave this open. It's fine. Okay, this is fun. All right, let me know what you guys think about this. So let's put these in a different order here. Let's throw this guy here. These mushrooms are all dusty. They're really dusty. Dusty shrooms. Okay. This is our array. Okay, we have big water bottle, our biggest element, our smallest element tied with this element, just different attributes, and then our middle element. Okay, that's what's going on. When we're going to initialize a loop, we're going to say for all the values in our array, we need to sort this array on top of itself. And in order to sort it on top of itself, we have to treat the array kind of like 2 arrays, right? We have a portion of the array from this point forward, so the 0 index that starts as sorted. Because if you think about an element by itself, this by itself is sorted. So if we just kind of divvy up the array after the 0 index, then the array is sorted on the left side. Cool. So that's what we're going to iterate for, right? Index 1 up to n, right? So n is over here, n is 5 or 4, right? 0, 1, 2, 3, so up to n. So we're going to iterate 1, 2, and 3. Cool. That's the first portion of the loop. Now, we don't want to use like pop or whatever, because pop will shift our elements down. So if we pop the element off, immediately our array becomes resized and shifts down, right? So that's not really what we want to do. We want to just take this element. We want to pull a reference to this element in a variable and evaluate from this position leftward, is this value less than this value? If it is, we just want to swap positions, basically. or not swap positions per se, but we already have this value saved in an external variable. So yes, it is here in our array, but we kind of have it stepped out and saved in an external. It's not popped, but it's saved a little bit outward. So if we'll do the evaluation, is the mushroom smaller than the water bottle, right? Is index array at index I or 0 smaller than array at index j, which in this case would be 0? Yes, the mushroom is smaller. So what do we want to do? We don't want to swap the elements because, I mean, we need to continually evaluate for the next left, the next left, the next left. What we can do is just we already have this reference pulled out, not popped, but just pulled out. So we can take the water bottle, save it into this place, and then just keep going. Now, naturally, if that's the spot that's next that's available, well, the loop will stop, and this item will just get added at that place. Right. In reference to whatever J initially was. Because that's our second item, right? So that happened. So that got placed, right? Perfect. Okay. Now, we started as 1 and we swapped. So the next item, our I increases up to the 2 index, or the third element, right? It started here, and we kind of mimicked a pop and insert by doing the shift over, and then by default placing. So now we're on this element, we eval. Is it smaller than this one? Yes, okay? Shift. That is saved in that spot. Boom. Is it smaller than this one? No. So by default, this gets placed at that J and saved. There's an available spot there. It has reference technically to the water bottle still, but we also we overrode the reference to the mug cup with the water bottle here. So there is a water bottle technically right here, but we're just going to override it and put it right there. Right? So we have to make sure that we have this saved in a variable, not popped, but just saved a reference to, so our array stays the same length, and then we can, once we have this saved, we can override and override. Right? So now we're on this element. Okay, the last mushroom. We evaluate, is this mushroom smaller than the water bottle? Yes. Okay, mushroom is saved in a variable. It's not, its reference is saved in a variable. It's not popped. It's still in the array. We have the access to this guy. We override here. We're here. Okay? Is it bigger than this one? Smaller than this one, sorry. Yes. Okay? This one, we override this place, and we move on. Is it smaller than this one? No, they're the same. So we're just going to, boom, right there. Sorted. What do you guys think? Ta-da! All right, I disconnected here. Let me come back. Oh. Okay, we're back. What do you guys think about that? Now we got some mushrooms here. We'll just keep off to the side here. How about? I think they're salt and pepper shakers. No? Oh no. Guess not. They would make good salt and pepper shakers though. How are they really not? All right, so now let's go ahead and code this. So I'm going to pull my work on the side here that I worked on at lunch here. But I'm going to try to do it just off the cuff here. So we have some results array because in this problem we're appending each iteration, each swap that a kind of like a screenshot of what the array looks like in our results and outputting the entire thing. All right, so so that's what the results is here for. So we have n length pairs because the array doesn't change. So we say for I, right, in the range of 1 up to n. So this is going to go, if we have some dummy array here of A is equal to an array of 4, 5, 1, 3, right? This would go say I is going to iterate, I iterate it, oh my gosh, iterate over values 1, 2, 3, right? On each loop. Iterate as values 1, 2, 3. Okay? Oh, you can't wrap in this, I forgot. Okay. So then we need to establish a J. But before we establish J, right, we need to take a reference of that I index of our array. So we're not popping the I index. The I index is what we're wanting to sort. That's the element we're wanting to sort with insertion sort. So we're going to say element to sort, right, is equal to the array, which in this case is pairs at index of I. Okay, so we're not popping, we're leaving our pairs array the exact same, but we're just creating an alias reference of pairs index I at each iteration from 1 to 2 to 3 as I as element to sort. Okay, that's the first part. Second part, we have a J here which is going to be the value that was left of our first index, the 0 index, to do the iterations over that sorted portion. So we need to establish a range on the sorted portion that will be consistent. So we can't just use arbitrary numbers. We need to use numbers that dynamically increase over our loop. So we're going to be using something like I, because I is dynamically increasing over the elements in our unsorted portion, and by default, after each iteration of I, an element is going to appear in our sorted portion. So our J is kind of going to inverse I in a sense, just by the actual size. J will first start off as 1, and then iterating over one value, and then iterate over 2 while they trade off. I think. So now we establish J as I minus 1 because initially I is at index value 1 at the 5. We want J, I'm sorry, to loop over the sorted portion, which starts at 0 and then will dynamically increase for each iteration of I. So we establish J which will be J will iterate over the sorted portion starting from index 0, right? So the thing is, though, is we need to move backwards from index value 1 because that's where we're popping off, values from. Or index value I, rather, right? We're popping off, if you think about it, we have this array. We're not popping, we're saving reference to. We're doing the 5 first. We're evaluating, is the 5 smaller than the 4? No. So I increases to 2, and so J needs to loop over up to I in this case. So over the 4 and the 5. So what we can say is, right, we need to continually loop while a certain condition is happening. So we will continually do something while the element is less than the element to its left, right? So while um, pairs at index, um, while element, sorry, to sort, because we already have that saved here, pairs index I, while element to sort dot, right, we want to access this element's, specifically to this problem, it has a value here of a key. So dot key is less than the um, the array pairs at index value of j, right? While it's less than the index value of j, so it's going to say, okay, this element 5 is less than, right? Remember, j is I minus 1, which is 0. So 5 is not less than 4, so this while loop won't happen. And so there will be no swap taking place of those positions, or like an override of 4 into the 5 position. And then 5 will override that position by default. This won't happen, and so because this is already technically sorted in its first point here. The key. What do you mean, Mahan? The key? Yeah, dot key. Right? We want to access we're evaluating over these specific keys in this specific problem. So, but we need to have another check here in this while loop because j is going to continually decrease to evaluate the next number, right? So if I goes up in the second iteration, right, I starts at 1. In the second iteration, I is 2, which in this case would be 1, the 1 value in this example array. Well, j is I minus 1, which is index 1. So we're going to, in this while loop, continually decrement or decrease j, but we can't decrease j past the point of 0. And if we try to do that, we'll get an index error or whatever when trying to do j minus minus past when it already is at this 0 loop. So we need to say while this and j is greater than or equal to 0. It will stop on 0 after doing the evaluation at 0, right? Now, that handles the looping over the all the values to the left of the one we're trying to sort at pairs index I, right? So we're starting on the 5. We're evaluating it to the value to the left of it at the 0 place. Is it larger? Or is it smaller? No. So it remains as is. We're going to so this is kind of a poor example, but then it remains as is, and then I is 0 here, so this isn't true here, and so this won't even be evaluated, and so it won't do this while loop. So we just need to then, what happens when we don't do anything? We just need to increase I. So that's the end of this example. Now, which I increases already right here. So now we're on the 1 at I index 2, right? So this has a value as that's position of 1 at the index I of 2. And j at this point is 1. 1 minus I minus 1. So I is 2, j is 1, right? And this is currently our sorted portion, the 4 and the 5. We're going to evaluate, is 1, see, while this element is less than the key and j is greater than or equal to 0. Well, our j is 1 at this iteration, the second iteration, because I is 2, and our element is less than. So this element 1 is less than the 5. You need to short circuit it. What do you mean short circuit it? I have no idea what that means. At -1, you check pair first before. At -1, you check pair first before j greater than or equal to 0. So while, I'll just keep moving here. So if this happens, what do we need to do? Well, we need to move the 5 into the position that I currently is. So, and we already have this saved here, so we can do that without overwriting what the position at I is. So the value at pairs index j will be equal to the pairs at index j plus 1. So we're going to, j is 2, or j is 1 here, right? I is 2, index 2. J is index 1. So we're going to save pairs j, which is index 1, the 5, as pairs j plus 1, index 2. J equals -1. So then what happens is, right, that does the swap, right? It reevaluates, is j, right? It does the swap, and so it'll reevaluate this condition, but we need to update j at this point in time. So j will minus equal 1 here, right? At this point, because we need to reduce j down to the 4 element. So right now it's the 1 is the I, and the j is the 5, right? We save the 5 over this spot because we have the 1 saved here. We evaluate then, is the 1 greater than the 4 or less than the 4? Yes, so the 4 then gets saved at this point, and then we decrease again. Oh, we can't do that because we can't go past 0. This while loop breaks after this condition, right? And so then what do we need to do? If the while loop breaks, we need to insert the value of I, no, insert the element to sort at j plus, so if j is, that got saved, is j plus 1. Pairs j plus 1 equals to pairs j. So we save the 5 pairs j, which is 1, at the pairs j at 2, pairs 2. We decrease j by 1, and we evaluate. Is the element, so j is 0 now. We decrease, so that brought us to negative, but then we need to go here and bring it back up because this still happened and broke the loop. And so j is technically negative here, so then pairs, pairs index j plus 1 is equal to element to sort. So, and then at this point in time, we have either done a swap, we have done a sort on this element. So we need to return dot append no, not that. We don't want to do, we need to do that and then do results dot append the pairs array at this point in time. So we say for I in the range of 1 to n, values air I, j I minus 1. While j is greater than 0 and the value key is less than the index value key, increase j, pairs j, decrease j, and set the value, append the results. Okay, so then here is what I wrote at work, what I was able to, with the help of the almighty orb, talking me through it. So, which is the same exact thing that we have here, but with just a simple array of just numbers. And so as you can see, this works. So with an and condition, don't both of these conditions have to be true though? So it won't even evaluate, it's not an or condition, so it doesn't matter the order of them though. That's what I thought. The order doesn't matter in an and condition because both of these have to be true. Because if I just swap these, it works still. Nothing changes. Okay. So then what happens if we go, if we have our results here? And then we go results dot append. You check pair -1. I'm not really sure following you. I mean, I have a working implementation here, so append the array here. So then we'll print results What happened here? That didn't work. Get out of here. There we go. So we get a 1, 2, 3. What's going on with this formatting? Oh, so this just appended A at that point in time. But this is still the same. Why am I getting different results sometimes? Okay, so this, I get the same array now every single time. Use 1, 0. Zero, 1. Appended outside the loop. Okay. Yeah, let's move this outside the loop here. Oh yeah, we want to append at each iteration of I. You're right. I'm appending the reference. Hmm. So now I'm getting just a single array of it sorted at the very end of the loop. Oh, so we want to append. Append A. Oh, but A is originally here. But then we do things to A. So this gives us the four things, but just the same iteration. Am I blind? What am I missing? You append the reference. You change the A all changes. If you want to check what happens in every iteration, spend it before decrementing the J. Okay, but I want to get this value as well, I thought. One, two, three, four, five, six, seven, eight. 1, 2, 3, 4, 5, 8. So what if I append a slice of J? What happens if I do that? But I don't want to do it on each movement. I want to do it after I decrease J. 5, 8, 8. So let's take this then and move it. We want it here. 5, 8, 2, 3, 4, 1, 2, 5, 8, 3, 4, 1, 2, 3, 5, 8, 1, 2. All right, woo! I think we got it. Well, I mean, think about it with the numbers. Like all my indexes and my conditions add up, right? It makes sense. But I'll look that up, yeah. Okay, so now that did that. Okay, so now let's try it here. I think we're almost there. Almost there. Okay, so we need to results dot append the pairs slice here. Now, what about the condition where they're equal? So by default, okay, so it will, if it's less than, so this condition will happen even if it's equal as well. So if it's less than, it won't happen, so it'll just do this. So it'll still maintain the order. Okay. Okay, so Should we run it? Run it, baby, run it. We want to return. We need to return results, right? Return a list of lists. All right, here we go. Ah! No! Oh, my heart. Oh, my heart. Oh, no. My output was 2 banana, 5 apple. What the heck happened here? Oh, I only have, here's a list, 2 lists. This one has 3 lists. So I'm only getting 2 lists here. So I need to append the current list as well. That's what I'm missing. Yeah, I need the current list. Yeah, we're gonna add pairs here. Basically copy a reference into this list. Will that do the trick? No. So we got 2 banana, 5 apple, 9 cherry. It wants 5 apple, 2 banana. Two banana, 5 apple. Okay, so pairs. You just put a slice in there like that? Copy? Oh! Bang! All right, let's get 5 big booms for your. You guys seen that video of that Costco guy where he's like, "Oh, David, I'm so sorry, your brother died. Let's get 5 booms for your brother." Boom, boom. So terrible. Boom. Okay. All right, should we submit it? Boom, boom. All right. Come on, baby. No. Oh. It didn't like a no list. Oh, so didn't want this. Doesn't want this. You suck. Okay, so we need to have, say, uh, we'll say if pairs. Right? Do that. We can just remove this. Okay. So this has to go X that out. If pairs, we need to results the append pairs like so. And submit. Yes! Boom! Boom! 5 big booms, John. Let's get 5 booms for John. 5 booms for John. All right, we got accepted here. Woo! Well, that's a good way to do it too, John. John said go if not pairs, return results with an empty list. So you could say if not pairs, return empty list. And then return results here. That'll work too. Oh no. What do we get? What? Line 119. Like that. If not pairs, return results. Huh. What am I doing wrong? Oh, shoot. There we go. Where did you come from, baby? That failed too. Output was 2 banana. Return the list. Then we need to go. Oh no, we'll go results here. And then we'll go here and go results. Dot append. Pairs index. Like so. Paris. Shout out to all the pairs. Boom! Boom! Nice. All right. Sweet. Do we have like an evaluation of time or anything? Do they give us that here? Is there like an evaluation? Like they have in LeetCode or Neet, yeah, LeetCode where you can see like the time complexity in your score? Guess not. All right, you guys. This was insertion score. Post in LeetCode. What do you mean post in LeetCode? Is this same question in LeetCode? Sweet. All right, so I'm feeling a lot better with insertion sort. It is considered one of the easier algorithms, right? One of the easiest, sorting algorithms. But look, like it's still you gotta have some complex, iteration here, and tracking. I mean, it's not too complex, but you have to follow it over two loops, so it can get easy to lose track of. So identical question. Anyone know what that question is on LeetCode? What's the number? Anyone know? Anyone know? Let's see. What's it called? It's called insertion sort. This guy? No. Um. This is a medium. Sort list. Sort by. This is in JavaScript, TypeScript only. Anyone know what the problem is for insertion sort? We'll look up what is the leet code equal to the insertion sort problem on Neet code. On Neet code, the problem that closely aligns with this is the insert interval. I just wanted to. It gives us like a time and a rank, and I kind of just want to. If it has a similar problem, I want to just post it on here to keep track of it for our leak code account. I don't know. Oh well, if you guys find it, let me know. Yeah, it also ranks your time and space to other people that solved it. Insert sortion list. We already tried this one. Given a head of a singly linked list, use an insertion sort and return the sorted list head. Oh no, I'm not doing that right now. Oh boy. What was the neat code question? It was just insertion sort. All right, cool. So we solved this one here today, insertion sort. We were stuck on this one yesterday, and I went home, or not home. I went offline and did some homework and really studied for a good, hour and a half just on insertion sort, on trying to, um, figure out the actual, you know, concept and logic behind it. I think my problem yesterday was I was understanding, I just didn't know right what insertion sort was actually doing. I was I was trying to deduce it myself. I was trying to figure out, do I want to start from the back? Do I want to start from the forward? Do I want to start from the ones place and then go back? Do I want to start from the one place and then go from the front? So I was just really ill prepared in my opinion for the actual problem at hand. I just didn't have the tools and definitions necessary, I think, to solve it. And so I went and took about an hour and a half um, of just learning and watching videos and doing those examples like I did with the water bottles. Like I last night after the stream, while me and my girlfriend were watching The Crown, we recently started that on is it Netflix? I think it's on. I kind of like those old timey, British shows or whatever. Um, I had my water bottles there and I was going through sorting them, trying to figure out different combinations for like up until probably about midnight. I got off the stream about 10:30 and we watched until about midnight, 12:30, and I was doing it the entire time trying to figure it out. It was really bugging me. So, but the water bottles, watching it happen live really helped to keep track of things. So, I'm going to have to go back to that model again in the future. So this was insertion sort today on Neat Code. So really, really cool that we were able to solve this one. Let's go ahead and shift focus into the small business manager for a little bit. And because we've been neglecting this a little bit for the past couple of days. So we got to keep some progress going and at least add maybe, why does it do this? One or two functions here to keep the progress moving along. What's the URL? Let me look. Um, uh, I'm not sure. I went to practice and I did insertion sort on sorting here. Okay, so we're back in the small business manager here once again. We can run our program here to see where we left off on. We can go to um, last time we left off on was saving the business information, right? So we can go to the settings menu, go to business settings, edit the name of the business, test name. and then go settings menu, and then that got saved. And so if we were to go main menu, exit, yes, and run this again, yes, um, settings menu, well, as you can see, test name stayed. So it's successfully doing that. Now, let's go to my, what we can test here as well is the item CSV. What I can do is I can make these values larger. So I'll make this 50,000 cents and I'll make this 500,000 cents. Um, and then I'll make the ones that combine, I'll make this like 1, 2, 3, 4, 5, 6 cents. So now if we go ahead and run the program, oop, yes, and go to into businesses.json, that didn't work. Let me exit. Yes. Oh, so it's saved. It completed it on save. So why not on load up? We need it on launch. So on startup, we load file. If business JSON has data in it, we create this. Oh, it is in there. It's just not internally. It is in there. It just doesn't appear until we save, right? So I think we should call then a save file right after this. So let me go to my my business settings menu. Let me call my save file function on business JSON. And then let's also paste this after we create here. So now if we go ahead and update the item CSV, let's make this 999999, and let's make this 888888. And then if we run, right, if I go to business JSON, these are the old values. If I press yes here, immediately updates live. So it is internally updating. It just wasn't doing the save and writing to the file. But I want to write it right away. So if they launch, then it calculates that revenue, writes it right away, and so it's saved no matter what. Because remember, in our business class here that we created a few weeks or days ago, when we initialize revenue, revenue isn't a parameter or an attribute given in the initialization, in the instantiation of the object for the business, but instead it has an initialize revenue function I created, which takes in the items out of the all items, accesses the date sold if it has one, takes the revenue, creates a a dictionary slice um, from that revenue forward for the date sold, and then so I can keep all of it in one area, and so it has this year and overall revenue look to it, which is really cool. If you reverse the order while array index j is greater than key, and j is greater than or equal to, Python would first try to evaluate r index j is greater than key before checking whether j is greater than or equal to 0. If j is negative, um, i.e. j is less than 0, Python will attempt to access an invalid index, which will raise an index error. Yeah, no, honestly, Mahan, it I don't know. It's that and condition, right? I don't know. We can talk about it, but I'm I'm, I'm not sure. I mean, all of the resources I looked up had it this way or a similar manner, where this both of these have to be true in order for this to come true. Like this is an and condition. Both of these booleans have to evaluate to true. So yes, the value is less than that index, and j is not j is 0 or greater at this point in time. I mean, it this whole line has to evaluate to true in order for this to happen. This right here to happen. Left side and evaluates left side of and evaluates first, then right side of. Well, I mean, yeah, if this is true, it's not going to do this until it evaluates this to true, though. Are you saying just to move this to over here just for time savings? You don't even have to do this extra constant evaluation, but it's still it's just a constant evaluation. If you put left of it array index j, yeah, in Python, this entire line has to evaluate to true at once, I believe. Problem is not true, problem is index error. Well, j always has to be greater than 0 for this to happen, so you'll never decrease j. I mean, you have to evaluate j first, right? So I guess you could say, like, if you only have one value in the index, in the array, right? It's technically sorted, and so j minus 1 will equal negative 1. But you won't even be able to do this, so you could just say if n is 1, then, return whatever. All right, let's move on. Don't matter. We got it right. Got the problem right. That's what matters. Let's keep moving. Okay. Thank you so much for joining me tonight, you guys. Tomorrow we will be working on watching the Harvard CS50X lecture on week 4. So tune in tomorrow and be back here tomorrow if you want to continue that course alongside me. Okay, so we have that updating now. So we need to allow the user to be able to update the actual categories and methods of this business as well. So the business class has, I had them in here, but I removed them. Where'd they go? So in my main, I have, so in business class, I need to add them here. Or are they in my expense class, rather? Sorry, they might be in my expense class. Yeah, so here, they're here. Categories and methods and expenses. So expense settings, if I go settings here, we have expense settings in option 2. If you haven't checked that j is greater than or equal to 0 and say rj, what if j is negative 1? You check argument j equals to -1 first, which is index error. Then you check if j is greater than or equal to 0. If you say you haven't checked that j is greater than or equal to 0, and say rj, what if j is -1? Well, in Python, I'm pretty sure that if you try to access a negative first index of only a single value, you just get the 0 value back in your specific example that you gave. Like if you have some array with a 0 in it, you say print array -1, you get the 0. It's the same as saying a0, but that might not be what you're referring to. Evaluate the index before it's used. Let's go down here. So I call pairs to I here. So the only way j that this would be false here is if j like falls back to -2. So if your original pairs array only has a single element in it, you would go back to -1. But if it's empty, you'd go back to -2. So I guess if it's you'd have to do a check if it's empty or have one value. Okay, so we have the business settings here. We need to let the user be able to add a category. So we'll do it's a class method. This is also going to be a class method for def add method. It takes in the class new method in the form of stir. If new if is instance, if not is instance new method stir raise value or attribute error. Word slash free must be a string. Let's say string, whatever. Like so, and we'll put an F out front. Oh, so it works because you already handled the case of the list being empty. Handled the case of the list being empty. Yeah, if it's empty, return results, which is just empty array. So if it's empty, you would try to do this, and that would raise you an error as well. I mean, because you couldn't do that. But if you had one element and you tried to, if it was empty, yeah, you would get a value error here. And you'd probably get one here as well, but you would stop here. You get a value error first here. Yeah, that's what I said earlier. -1 goes to the last element. So if you print the -1, you'll still get reference to the first element on a list with one element, right? in this example here, where I had array A is equal to a list of 1, print A at index -1. It's a Python thing. If it works in Python, it's all right with me. That's what we're focusing on right now. We can come to cross those bridges when we get them in other languages. Okay. So I did this. Is this really necessary? I mean, it's whatever. If is not, if new cat class categories add new cat. Class dot methods. Add method. All right. Cool. It does, but right now it's not. Array index -1 is not index error. It's array n-1. So n 0. Okay. So we add that method here. Now we have the add cat method as well. So we can go back to our main program here. In the expense settings menu, if the user presses add a new category, we call expenses categories add this. So what we can do now is just call, instead of this, call expense dot add cat, then expense dot add method. Right. We'll title case given. And then we need to save these methods in these categories, right? So we need to expense settings. So we need to have, this is business.json, our expense. I don't want to have to make another JSON file. So we save it in business.json. Hey, Alan, welcome. Appreciate you joining me. Welcome, awesome for you. What you been learning right now? What level are you? All right. Mahan, we can talk about the C implementation of it later. I just wanted to move on to something else. I don't want people to get too bored of the same thing over and over. We worked on that a lot yesterday, so we finally solved it in Python. So let's just move. We'll come back. We can chat up about it offline. Um, so where do I want to save the? Because in my expenses.json, we're saving expenses via item number, so we can't really like throw it in here somewhere, unless we throw it at the very end and then iterate the length of n-2 for the load expenses. Hmm. Hmm. We'll probably have to have just a. I mean, I kind of want to save it in the businesses.json though, because I have room in here for it to go. But it pertains to the business, but it also pertains to the expenses. But the business itself has its categories for its expenses. So, but it's in the expense menu. Do I want to, do I need to throw it out of the expense menu and instead put it in the business menu? But it's an expense setting, it's part of generating expenses. Oh, so hard. Abomination Alt 2, in my opinion, Scratch is easier than Python. Oh, awesome. Thanks so much for that tidbit. Yeah, we've been learning Python for about half a year now. We've been teaching ourselves completely, independent here through books and various resources. We finished today chapter 8 in trees, in data structures and algorithms in Python. So we've been reading the entire book live on stream, word for word, example by example. So we finished chapter 8 and are now taking a stab at the end of chapter 8 practice problems. So we finished the first one here, but we moved on and did a leak code problem or a neat code problem and solved this one in Python. And now we're just working on our personal project here, um, the small business manager. You can nest the expenses JSON inside the business JSON. Wouldn't make sense because expenses are part of businesses, right? So if that's the case, what I do I need to go down the rabbit hole then of making my items a JSON file as well and just get out of this CSV? That's a whole task though. That's a whole task. Because we've already established. I mean, we're if we're gonna keep going JSON, I like your idea, John. That's a good idea. So if we have a business.json, well, that raises the question then is should I take my item class and nest it in my business class? No, because the item is on the individual basis. So I'm already pulling from the business class the all items that is saved, in the system. So I need to keep this separate because it's on an individual item basis. But if we're going to nest inside of a JSON, business JSON, the expenses JSON as well, we might as well do it with the inventory too. Ooh, what do you guys think? Hey, Sunny, Sune, I appreciate you coming in. Thank you for leaving a comment here. How and when did you first start learning Python? Yeah, I started learning Python about half a year ago, just teaching myself through after my 9 to 5 job. For those that are new, my name is Michael. Thanks so much for joining me here. Just creating a kind of a safe study environment. I really like independently learning and teaching myself things outside of a formalized institution. I graduated college back in 2021 with a degree in human biology and a minor in chemistry, and I work as a chemist for a biotech company right now, and I've been doing that since right after I graduated high school. I got a job, and so about 6 months ago, though, I had the realization, I want to keep learning. I'm tired of just coming home after work and sitting on the couch and really doing nothing. It's not really serving me any purpose, and quite honestly, I'm kind of forgetting a lot of the things I learned in college and a lot of my math and everything. And so I need to keep, I paid for this education, and I need to keep, up with my, up to date. But I also really, really, find computer science super, super interesting, and I kind of developed a little bit of a knack for it and a little bit of a passion. And so we've been just focusing solely on computer science and mathematics basically for the time being, and it's that's what I enjoy doing right now. So yeah, if that sounds like something you're interested in, then please consider following along the channel. We've been growing quite rapidly. We're about to reach 1.1K. So thank you guys so much for supporting me and supporting yourselves, because this is not only an environment just about what I'm learning, but also what you're learning. Like if you learn something from what I'm doing on the stream, then great. But if you also are just using the stream to hold yourself accountable, I stream every day around 7 p.m. PST, and so I've been doing that for past about 2.5 months, and so it's a way to also hold yourself accountable if you find yourself procrastinating work, pushing things off. You can throw on the stream at 7 p.m. and that's a dedicated, 2.5 hours, 3 hours of study time of work and getting your stuff done alongside me with whatever you're working on. So yeah, it can be used to whatever kind of as a whatever device you would so fit. What's the name of the book you're reading? Do you like how it's teaching you so far? So yeah, if you're a beginner, I highly, highly recommend. I started off with Harvard CS50P, and then I moved and filled the gaps of that course with the Python Crash Course book. I have a free copy of this book, a PDF, in my description in the Discord below, and it is a kind of a roadmap of my entire learning journey so far with DSA and Python, Python Crash Course, CS50P, CS50X that we're taking right now. So if you're a beginner programming wanting to kind of follow some structure with another independent learner, then this is a great place to be because I've been pretty good so far about keeping myself to the grind. So yeah, I provide all that in my Discord link below. Um, if I were me, I'd go full JSON. Yeah, that's probably what we need to do, John. Yeah, we need to bite the bullet here. Probably tomorrow. Um, Business class can have an attribute items, which would be a list of its items, or that dictionary, all items, right? So we could leave the business class how it is, right? It pulls all items from the parameter all items given in the constructor, which is just a copy basically of the current all items that are loaded, in this file here globally. So, and then we could do the same for all expenses too, right? We could initialize all expenses. That's what we are doing, but we're not doing any initialization because we're just loading those expenses. Maybe we need to do a similar function for this for total gross or total expense amount per year, and have all expenses and then have a operating expenses attribute for the actual cost of the expenses, like similar to how we're displaying these in that format, like so. So then we can take an expenses yearly breakdown and subtract 2025 from 2025 to produce our net profit, our net revenue, right? Um, Business class, yeah, I got you. Okay, I read that one. Just make a function that reads CSVs and makes convert to JSON. This is why they can give an Excel file which automatically adds items to the database. That's a good idea too. That's a really good idea actually. So if we write a function that converts JSON to CSV, so the user in the settings can have the option to download a CSV of their current items so that they can populate them into Excel, or they can have the option to do the verse and preload items from an existing Excel. The only thing is all the CSV would have to have the same headers unless you dynamically create attributes. That's a perfect task for chat. We are chat GPT, John. What do you mean? We are chat GPT. We can't let it take over. If you intend the business class to be the master class as the whole of the whole program. Yeah. The business class base, so the item class and the expense class, that's on an individual item and expense basis. But the business class will have, it has those all of those individual items loaded into it, and it has all those individual expenses loaded into it. And so maybe we should create, so then we should have the file saving happen all at once as well. It's good that we're talking through this. I know we're not really writing code right now, but we need to think about this process so that when building projects, and from my understanding is that I like to do this thinking and brainstorming because when I actually go to write code and I get downstream, if I have proper planning, I reduce the amount of possible changes and errors I might find. So I really like to think through things to set it up for a downstream effect. Maybe you can order it in alphabetical order. That way they're all the same format. Oh, the headers in alphabetical order, you mean? So the headers right now are kind of just in the cascading process of item, life cycle from generation of number and name and size to initial cost, date created, the date listed, listing price, date sold, sold price, shipping method, shipping price, and then just some placeholders for additional attributes I was maybe going to implement. But it kind of just follows the current cycle and then with an active status as well. Oh, for sure, it's a great to spend time on design. It obviously saves more time in the long run. Yeah, definitely. So, if you guys are following along with me here and you're thinking, well, he's not actually writing why isn't he actually writing his program? Well, we'll get there, but we just need to really process the actual structure and think with a future mindset because we don't want to run into things that we're going to have to change with a bunch of spaghetti code. I've been really trying to focus on you know, in my last project, the task tracker, I had a lot of instances where I went to update things or I had a bug, and then I had to update a little piece here. I had to go into the class, update a little piece there. I had to go into the file, little piece there. I had to go into the file that's the function that saves the file, update that function. So it was just a bunch of spaghetti code and I wasn't really able to make changes very efficiently. So this program, I'm really trying to flip my mindset and really focus on, the structure of it and keep it efficient. So like we've created these various, auxiliary functions or operational functions here to help aid that process, like create menu and things like that, which generates these menus for us automatically. And then, but we also have lacked in our organization because we are getting pretty deep here in size. But I started to kind of clean up these functions names. Like instead of just main, this is now start menu, main menu, inventory menu, run add item, find edit item menu, edit item, run view inventory, run transactions, transact item, settings menu, business settings, expense menu, add expense, expense settings. So it's pretty straightforward, but it does take some time to kind of sort through. But um, all right, anywho, you guys, I am yet to have any dinner. I came home right from work and hopped on the stream. I had lunch at like 11 o'clock, so I'm pretty starving. I really want to just hop on here and complete the leak code and do finish the chapter 8 with you guys. I know I was a little bit later coming onto the stream tonight. I really apologize. I just had a late day at work. I got caught up. I had my current product I'm building is currently at about 400 liters, but it's a really viscous serum, pertaining to kind of like biological elements and human plasmas and things like that. So it just I probably chewed through about 10 filters, 30-inch filters and each time you have to depressurize the vessel and then clear out the fluid, depressurize, swap sterilely, like with alcohol and proper equipment and every sterilely swap the inside of the filter. And I probably clogged. I had an apparatus of about 5 different filters cascading from 7 micrometers um, to 0.4 micrometers, and I had 5 cascading segments, and I clogged, you know, almost every single one probably twice. So I spent 6 hours alone doing the filtration from 1 o'clock to about 7 o'clock. So sorry about getting on late, but I did want to just hop on here and spend some time hanging out with you guys like I do every day. Again, I really, really enjoy the time I spend hanging with you guys and learning. And it's really a great opportunity to just learn in a kind of a stress-free and fun environment. I'm really trying to make this just a fun, enjoyable process, learning how to code. It's not supposed to be competitive, trying to force myself to do this to get work or a job or you're anything like that. It's really about just understanding the overall process, enjoying the overall process, and learning to love to code, right? I really want to actually love to code. I don't want to have to, oh, I gotta code this. I don't want to know. I want to, oh, I gotta code. It's cool. Let's do it. It's fun. Is there a reason why all items is a dict instead of an array? Is it because the key could be something unrelated to the number of items? So um, the currently the all items is a dictionary instead of an array because we're able to use it kind of like a hash, whatever. We haven't gotten to that in our DSA and Python book, but someone suggested it and kind of explained what it would do is we are able to, because we might have upwards of thousands of items within this database, or hundreds to thousands. We need to access them pretty quickly. So by having the item number resemble the key in the right, the item number resembles the key, kind of similar how the expense here is we can directly pull the item number from our database. So you physically have on hand like the item with a tag on it that says item number one. You sold that item, but you don't want to have to go through your database and figure out which, what you named it, what day you bought it. Maybe you don't really, you have that information, but it's just not super like fast. So, but you have the tag in front of you with just the item number on it. So all you have to do is to search the item number, and it pulls this object in constant time from the memory. That's why we created the, um, now this is the expenses, but it's a similar approach where the item number is the key of the dictionary, um, for each, you know, dictionary. It's a dictionary of dictionaries. Or no, it's just a dictionary with the key, not a dictionary of dictionaries. No, it's just a dictionary where each key is an item number and the value is the object itself of the item. Okay, so tomorrow, you guys, well, I'm going to wrap it up here for today. So thank you guys so much for joining me. I really, really appreciate it. Today was January 28th. We streamed for 2 hours and 17 minutes. Again, I apologize. I was late. I had a late day at work, but I still was able to get in 2 hours of studying tonight. I'm gonna wrap it up today, but tomorrow we're gonna be watching the Harvard CS50X Week 4 lecture. So if you're a beginner or new programmer wanting some exposure into a more formalized course environment, then please, I highly consider taking that course alongside me. It'll really, really set you up for success in the future with starting with C and just getting general computer science knowledge and full stack exposure with C, JavaScript, SQL, Python, um, HTML, CSS. It really goes over all those. It's quite elaborate. But also, if you guys are interested in taking Harvard CS50P, I've also taken that course. And so, if you have any questions regarding that course or want notes, then join my Discord and get access to that information as well. But tomorrow we'll watch that lecture, and then we'll probably continue working on the small business manager. I got to keep going on this. We're really getting close to having like a working version here. So at least something that can actually manage items and expenses, and then we can add in additional features for, the whole point is once we can add items, expenses, and have the business set up, well, once we have that structure, we can push the code really, and then we can just start adding features on top of that. We can say, okay, we want to add more, statistics that the business class can display, not only its revenue, but maybe its cost per customer or customer acquisition cost or something like that. So we could, continually update and push new features on top of just, we're just trying to get that bare bones structure so we actually have something to work on data wise, right? So we're almost there. So we're going to keep moving on this. I think like we had some suggestions today, we're going to put forward is we're going to move and transition the items from a CSV environment to a JSON environment. And then we're going to potentially nest, I'm not sure. We're gonna potentially probably do a lot more nesting in the business class of more specifics, items, and business information. But um, we had a suggestion to maybe nest all of the expenses and items itself into the business.json. So we'd have to think about how we could do that. I just don't have a ton of practice with JSON. I know just the basics, but we'll get more nonetheless, and it'll be all good. So thank you guys so much for joining me tonight. If you enjoy this kind of format, please enjoy the time here. Please consider throwing it a like. It really helps for YouTube to keep suggesting our videos to and our stream to new new friends. Our community is really growing here, and the more people that we get, helping, suggesting things, helping each other, it really will just compound, and we'll have a whole, network of really smart, really, you know, um, friendly people that can all, work together to accomplish great things. So yeah, that, and then if you're also considering following along and subscribing, so we can chat in the future. So thank you guys so much for joining me. I'll be back tomorrow at 7 p.m. PST. I'll let you guys know in the Discord if I have any other blunders to my scheduling. Um, if you want to add online database, its future is easier. Okay, so we'll probably be just keep the files into their separate JSON. So we'll convert the items CSV into a items.json, and then just keep the and then have that, because I like that it's just in one file. I think it might be cleaner that way too as well. Um, I mean, the files, they're not going to get too large. It's just textual data, so it's not going to get like, it's not videos or PNGs or things like that. So anyways, that's enough of my ramble for tonight, guys. Thank you so much for joining me. If you guys want to chat with me offline, ping me on Discord. I'll respond to questions and things there. I had a lot of people reach out to me on the Discord lately about how to like start projects. It seems to be like the number one asked thing that I've been getting kind of uh, repeatedly asked, and a lot of other people have been suggesting a lot of great things. A lot of people seem to be stuck in that tutorial kind of watching those over and over again, and so I suggested that I might, make a video, a short video about how I actually started these projects, just to, show you some bare bones, like getting things going. But in all honesty, you guys, just really quickly, is it just started as one simple function of me getting input from the user in a creative way. I created some sort of menu using indentation and options that they could select using a while loop. And then from there, I had this menu and I just jumped, made another menu. And then all I needed though was an idea. So it really just comes down to an actual idea and then being able to convey that into code. Now, the idea does not have to be something like you're reinventing a wheel. No, like you're a beginner programmer, whatever you're going to make is going to be cool relative to you, right? It's going to be cool for you because you're new. So I didn't reinvent the wheel with my inventory storage system. I didn't reinvent anything with my task tracker, but I made something 100% unique and original. I didn't make a follow a tutorial or anything. And by doing that, I really had to think about how I wanted to build things, think about how I wanted to manage things, and then actually implement it. And so it really projected me further than I think watching tutorials altogether. So I really, like I said, as I don't really even want to make that tutorial really, because it kind of defeats the purpose of actually coming up with the idea on your own, and gaining that insight and that ability, because it is a skill at the end of the day to have like that creativity to think of, project ideas and actually convey them here, and try to put them into words and whatnot. So um, let me know what you guys, think about that. But I could take, 30 minutes on the stream, this week sometime, to just do a quick segment of how I got started. But let me know. I'll talk to you guys later. I'll see you guys tomorrow. Sorry for my ramble, but